Hello everyone, my name is Aishwarya. Today I am excited to present to you a demonstration focusing on the hotel reservation use case using SQL. Let's take a look at the schema of a reservation system. We have several tables such as rooms, guests, reservations, bookings and payments table. Let's switch to SQL and see how we can implement queries to interact with this database structure. We can switch to a specific database schema using the use command in SQL. This command allows us to set the active database schema for executing subsequent queries. Now let's start by inserting a new room into the rooms table. We can insert a new room into the rooms table using the insert into command. Let's update the price of the room to 301 to 3000 rupees. We can update the price of the room using the update command. We can describe the structure of the room using the describe command. Now we can delete a room from the rooms table using the delete from command. The drop table is used to drop the entire table. We should avoid using the drop command. We can retrieve data from a table using the select command. We can filter rows based on a condition using the where clause in SQL. Aggregate functions in SQL like average, sum, count, max and min summarize data by performing calculations on a set of values and returning single results, facilitating efficient analysis and reporting. We can perform aggregate functions like average to calculate the average value, and sum. Aggregate functions like sum can help us calculate the total value. Joins in SQL allow combining data from multiple tables based on related columns, facilitating comprehensive data retrieval. The main types include inner join, left join and right join, each serving specific purpose in relational database. Understanding and appropriately using joins are crucial for effective data integration analysis in SQL queries. So let's run this query. So window functions in SQL operate on a set of rows defined by a window and perform calculations such as aggregations and rankings within that window, offering advanced analytical capabilities for querying and analyzing data. The rank function assigns a unique rank to each row in the result set, which gaps in ranking for tied values, while the dense rank function assigns consecutive ranks to rows without any gaps even if the values are tied. So let's run this dense rank query. So the case statement in SQL is a conditional expression that evaluates a set of conditions and returns a result based on the first condition that is true. We can use the case statement to categorize data based on the conditions. This SQL query retrieves the reservation details and categorizes the total amount to high, medium or low based on predefined thresholds, presenting them as a reservation level in the result set. The case statement evaluates conditions for total amount and assigns corresponding labels, enabling a clearer understanding of reservation pricing. The subquery in SQL is nested within another query, allowing for more complex filtering and calculations based on the result of an inner query. This particular query retrieves reservation details based on the reservations table, where the total amount exceeds the average total amount calculated from the same table, leveraging a subquery to dynamically compute the average value. Let's run this query. So here we get the total amount after running this query.